Hello everyone, I'm Anindya, and today I will present OmniCount, a novel framework for multi-level object counting that integrates semantic and geometric priors to achieve superior performance without additional training. Our work addresses the limitations of traditional class-specific and training-heavy counting methods by proposing a robust training-free approach. Traditional object counting methods are limited by predefined categories and require extensive training data, making them impractical for open vocabulary applications. These approaches often need manual exemplar inputs and struggle with dense or occluded scenes, requiring multiple passes for multiple categories. OmniCount solves these challenges by providing a single pass, multi level counting framework that is training free and works across open vocabularies. OmniCount is built on an open vocabulary framework, enabling it to count objects from diverse categories without category specific training. Our framework processes multiple categories in a single pass, making it faster and more scalable than traditional methods. OnView consists of four main modules: the semantic estimation module, the geometric estimation module, the object recovery module, and the class specific counter. We start with the first component of our module, the semantic estimation module. The semantic estimation module uses open vocabulary segmentation models like the site adapter network to generate binary semantic masks for class-specific regions. It takes in an image and the category level texts as inputs and generates semantic masks for each category. This facilitates OmniCount for open vocabulary class-specific segmentation of multiple categories in the image. Due to the open vocabulary nature of the site adapter network, it can segment objects from various categories without requiring any form of training. Now we move on to the next component of our module, which is the geometric estimation module. We use depth-aware processing to refine the masks and recover accurate objects, utilizing depth maps from models like Marigold. It incorporates geometric information by recovering pixels missed out by the semantic estimation module for better accuracy during occluded and dense scenarios like human crowd or fruits in a fruit market. It helps in better object delineation and improves accuracy in those scenarios. The object recovery module is one of the most important part of our module. It uses KNN to refine segmentation masks by analyzing semantic and geometric features. Reference points are then selected from the masks, and KNN evaluates their proximity to enforce category uniqueness and spatial consistency. Overcounting is being corrected by merging redundant regions, while undercounting is addressed by recovering occluded objects using depth cues. For instance, in dense scenes, this module separates overlapping objects like heads in a crowd, ensuring accurate counts. This refinement ensures OmniCount's robustness across dense and multi-level scenarios. Finally, we pass each of this refined region, along with the semantic guided reference points, through SAM to obtain proper object counts for each category in the image. Another contribution of ours is the creation of OmniCount 191, a benchmark dataset designed for multi-level object counting with diverse annotations. It has 30,230 images across 191 categories, with annotations for counts, points, bounding boxes, and visual question answering tasks. Our dataset comes with diverse annotations from diverse sources, filling a critical gap in the field and offering a comprehensive benchmark for evaluating multi-level counting models. OmniCount achieves state-of-the-art results in both multi-level and single-level counting tasks, outperforming existing models in both training-free and training-based settings. We validated the results on OmniCount 191 and multi-level counting benchmarks like the Pascal VOC and single-level ones like FSC 147 and CAR-PK, showing its versatility. Here are some examples to illustrate OmniCount's ability to handle dense scenes, occluded objects, and small instances effectively. The combination of semantic and geometric priors, synergized by the object recovery module and efficient reference point placement, enables precise counting across diverse categories. In this slide, we analyze the performance of different priors used in OmniCount. First, we analyze the importance of depth refinement in our work. OmniCount enhances SAM segmentation performance using semantic and geometric priors. In our experiments using the OmniCount 191 dataset, we show that the absence of geometric priors leads to a significantly higher error rate in both metrics, demonstrating that SAM struggles with oversegmentation and overcounting without geometric priors. Specifically from this table, we can see that without using the geometric prior, the error rate increases by 56 to 58%. This suggests that SAM's performance suffers when it lacks structural and geometric context for occluded objects. Next, we analyze the importance of the reference point selection method. OmniCount employs a reference point selection method based on the feature activation from the semantic priors. These reference points are then fed into SAM for improved segmentation and object counting. Compared to SAM's default everything mode, which selects uniform point grid, our results show a clear advantage of using these reference points. Specifically, with uniform point selection in SAM's everything mode, it leads to a 67 to 21% increase in the error rates, showing that the reference point selection reduces overcounting and improves accuracy. Here are some visualizations from the OmniCount 191 dataset. You use OmniCount to count the different instances present in the dataset. As we can see, OmniCount can count objects across various scenarios with various densities accurately, encompassing vast diversity in classes, starting from cars to human beings to animals to birds and so on. Here are some additional visualizations from the OmniCount 191 dataset. We encompass different classes from different scenarios, like fruits to the natural world, to the supermarket, and whatnot. Here, OmniCount can handle each scenario very efficiently. To summarize our work, OmniCount introduces a training-free open vocabulary framework for multi-level object counting, leveraging semantic and geometric priors for superior performance. The OmniCount 191 dataset sets a benchmark for the field, fostering future research in multi-level object counting. OmniCount represents a significant step forward in making object counting more scalable, efficient, versatile, and accessible for various real-world applications. Thank you. Please visit our webpage for more details about our work.